going to turn this over with an introduction to Kaylee Dankevy, who is in the middle of your screen right now and waving, and in an InGoal hoodie. My apologies to the gentleman who she's going to introduce on either side of her, that I have not sent extra hoodies. They'll be coming. But anyways, Kaylee, just take it away. Introduce us. We're a person short as well on the expected attendance here. We've had some, or we're maybe having some exciting news, but I'm just going to let you introduce the team and explain the environment, what we're seeing in the background there in terms of the testing labs, and then we'll get started.
Yeah, for sure. So like Kevin said, my name's Kaylee. I'm the product manager for the goalie category here at CCM. I've been with CCM for about 4 years now. Previously coming over from years on the retail side and working specifically in goalie there. So like Kevin mentioned, I do have 2 others with me that are representative of basically our team at large. These 2, Ryan and Frank, are fundamental to our team, but we work closely with our innovation team, our stick team, our skate team that are all working on goalie specific products. We have 1 designer, so I'll introduce him before these guys can introduce themselves. Francis, you've probably heard him mentioned before. His child that was supposed to be delivered in September really wanted to try to make it to this InGoal seminar. So Francis is currently at the hospital with his partner delivering a new little boy, so he couldn't make it here with us. But from there, I'll take it over to Frank, one of our designers. So,
yeah, my name is, well, people call me Frank. Actually, my name is Francois, but I've been working as a designer in the hockey industry for, I guess, 14 years now. I've been working for some design consultants as well as some hockey manufacturers. I've been with CCM now for 2.5 years approximately. And that's about it.
And then next up, I have Ryan here with me as well.
Hi, so I'm Ryan. I'm a product engineer for the goalie, the protective, and the helmet categories. I've been here about 3 years now. I started in the lab doing a lot of testing, and now happy to be working on the product side, doing a lot of research for the advanced team, a lot of stuff for the innovation side of it, and working a lot in this performance lab up here that we've got. That's about it for me.
And I guess one last thing we should mention is Frank and I are lifelong goalies, but Ryan is so dedicated to the cause that he actually took up goaltending to have a better understanding of some of the tests that he was executing and the equipment that he was studying. So he's not only an honorary goalie, he's like part of the goalie fraternity now. So yeah, we're talking all goalies here today.
So in other words, I definitely got to get an InGoal hoodie out there. And I can relate to that personally as someone who started writing about goalies and was so fascinated about it, I had to try. Before we get into some of the product, actually, that's a perfect segue. As I said, folks, if you've got questions, some of you have submitted them in advance of this, but if more come to mind, use the Q&A button at the bottom to submit questions. But we did get one from Brett Hubeli. Hopefully, again, Hutch knows I'm brutal with names. Hopefully I got that right, from Calgary. He wanted to know, and I thought it was perfect right now, as you guys are introducing yourselves, how does one get a career? How does one start a career in equipment design?
Well, that's a good question. I mean, for my part, I was very lucky. Like right out of university, I was offered a job at a consultant agency that did design for all sorts of sporting goods manufacturers. So we did hockey products, but we also did ski, snowshoeing, baseball equipment, and we did all sorts of things. And so that's where I got my first experience designing soft goods. My training and the training of most of the designers that I know that work in the hockey industry is generally industrial design. So I have a college degree in industrial design and I have a bachelor's degree in industrial design as well. And I think the bachelor's degree is probably the degree that is the most common amongst other designers that work in the hockey industry. There are other avenues, though. A good buddy of mine in a company where I used to work before had a bachelor's degree in fine arts from the Guelph University. So that is, you never know. I mean, when you're really, truly passionate and you've got the creativity and the skill, then it's the key is to know the right people and be able to send your resume to the right person. And also living on around Montreal is also a good assets because most of the manufacturers are here that I know of. That obviously there are other, most of the big hockey companies are in Montreal. There are other goalie specific manufacturers that are not in Montreal, but the big hockey companies that do head to toe are centered around Montreal.
And Ryan, what about like from the testing side? Can you give us a little of your background and how you got into this? And if somebody was looking for a career in it, what types of things would be involved? What type of path you'd recommend?
Yeah, so I came out of mechanical engineering at Concord University here in Montreal. So I came out of there passionate about hockey. My mom would tell you I was probably born with a hockey stick. So I've always wanted to work in the industry. When I realized I didn't want to make the NHL or could not make the NHL, I took the other route and said I'll keep working with hockey equipment. So I applied here in the lab as a technician and worked my way up. Now I'm a product engineer.
Kaylee, can you give us a little bit of your path? I know you mentioned it working in retail before, but how'd you go from a passion for playing and loving the position to working as with CCM?
To Frank's point, I'd say mine is a little bit kind of off the standard track maybe, but it was kind of built around just a passion for goaltending and hockey as a whole. So, just briefly when I was in grade 10 and you're in careers class and they said, you have to talk about something that you're confident in for 2 minutes. So I said, I'll talk about goalie pads. So I talked about goalie pads, just, right there in grade 10 in careers class. And then I actually have a teaching degree. So that was kind of what I thought, because working as a product manager in a goalie category never really seemed like a realistic goal. But I started in retail when I was pretty young, always specific to goalie equipment, built up a few roles on the retail side, including coming to CCM about 8 years ago with an opportunity to meet Sonia, who Kevin speaks very highly of, who still works for CCM, but was running our goalie department for a long, long time, a legend in the industry. And my boss said, you're going to meet Sonia today, and you're going to want to follow in Sonia's career path. And then I met Sonia and I did want to follow in her career path. And then, a few years later, I had a chance to come on board with the CCM team, and here we are. So one good thing led to another.
And for those that maybe don't know, Sonia DiBiase, a big part of sort of CCM goaltending for years and years. And if you want some of the history and background, I think our first episode ever of the InGoal Radio podcast featured two people, Roberto Luongo and Sonia DiBiase. And I think to this day, most people tell me the interview they remember the most, with all due respect to Lou, is Sonia. So make sure if you haven't already, go check it out. Kaylee, we're going to put that teaching degree to good use today. You're going to educate us. This is going to be a little bit of a mixed session. Part of it is going to be eFlex 5 and some of the new, the pads, some of the changes in the gloves. But we're also going to talk a little bit about the R&D that goes into it, some of that process of designing, manufacturing, and get a little bit of a feel for behind the scenes, how you come to that product. So I think when I think of eFlex 5, one of the biggest changes, for me in this line would be the rebounds and the changes in the foams, and the fact that you've got this new control foam available, but also for the first time a max rebound technology that's designed to sort of kick pucks out further, give you a little more time to recover, transfer a little bit more of that energy right off the pad and shoot that puck out. So I wanted to ask you and your team, whether it's Ryan in terms of testing, can you walk us through the process of testing and getting to this stage where how these foams behave and how they're going to work for a goaltender in terms of finding the foams, testing the foams, and ultimately putting them into the pads?
So, I mean, I'll just jump in quickly and then Ryan can walk us through in more detail. But essentially, like, I think that's a pivotal part of eFlex 5 and what we were looking to achieve in the pads. You know, with eFlex, we have a lot of goalies that have almost grown up with eFlex. It's their go-to product line. They've come to know and love it. So with that family, we're always looking at, you know, how can we enhance it for this, you know, kind of current generation of goalies, but also make sure that someone that had a previous eFlex 4, eFlex 3 would still really love it. So we saw an opportunity with the foam to try to evolve it a little bit, to take it from just being a very soft face generally to something that had a bit more of a performance element, looking at how even goalies that like softer pads do at times want to be able to direct pucks with a little bit more accuracy. And then again, even just looking at the rise of kind of the stiffer pad and goalies that like eFlex, but might want to have a lot of force behind that rebound direction, and how could we meet their needs as well. And thus became this big focus on foams and what you're seeing with control rebound, and then the custom option of max rebound. So we did need to look at foams. We needed to do a few more kind of studies to specifically see what would work well with eFlex. So I'll turn it over to Ryan and he can detail some of that for you.
Sure, I'll walk you through it, and if you want, Kevin, you can maybe pull up the video too to give a nice little example of what we were doing up here. So the process starts in the performance lab up here, where I suppose it starts with the question and then we work our way up here. So what we're doing is looking at kind of how the pad is going to react from an impact and how we can take that to the lab and figure out what kind of material testing we should do. So you're looking at sort of a high-speed video of different angles, different types of deflections, types of saves that are happening. And then what we do is we take that back to the lab and we recreate them with just the raw material testing. And we work through a bunch of different iterations, bringing it back up to the ice and seeing how it reacts and getting the right feel from the material. And then basically putting it in there and figuring out what the best way is to get the pad to react.
And I think further to that as well, you know, Ryan's talking a lot about the testing, but even working really closely with him is someone, well, is literally Frank, who's actually the one kind of sourcing the foams and getting us to the point where we even have something to test as well.
Yeah, I mean, we work closely with our foam manufacturers to always be on the cutting edge of what's new and what are the new materials that are being released. And so after a couple of years, you know, you start knowing what are the typical characteristics and features of each and every foam that are out there. And so before we start a project like this, we already have a pretty good hypothesis, you know, and so we don't have to venture left and right. We can already start with a pretty narrow array of foams that we know have the right characteristics, not only for the rebound, but also to give us a product that'll be durable through years and years of you know, the abuse of hockey goaltending.
And that testing process, Ryan, I was just curious, there were two sort of parts to that video. There was parts where, like you said, it looked like it was just material, and then almost like a little bit reverse order. We saw the goalie first, sort of in the stance. Can you walk us through like that sort of process in that stage? I'm guessing it's materials first. And do you go through points where you're going through the material testing and you're like, yeah, you know, maybe this, before you even get to the point of putting in a goalie pad where, yeah, no, this isn't what we're looking for?
Yeah, definitely. I mean, there's a lot of materials that we went through that weren't giving us what we wanted. So we start up here trying to figure out the angles, get everything right for the recreation down in the physical lab. And then it's just going through the process of going down to up to the performance lab, back down, and trying the different setups, different assemblies of the different foams. A lot of iteration to get to where we are.
And can you talk a little bit about where you arrived? Like was there any aha moments where it's like, this is the one? How many hours of testing are we talking about when you get to that point? Is there a level of excitement as a designer when something pops, literally in the case of a rebound, the way you expected it to? And then maybe walk us through, for the people that are looking for actual questions, about the differences between the two foams available specific to eFlex 5. You know, what are some of the numbers or performance characteristics of the two, and how am I going to feel that? You all play the position. How am I going to feel that as a goaltender? What does control feel like compared to Max?
I mean, I guess, like, so the thing is, it's like, it is a very kind of collective process overall in terms of, getting the test results, analyzing it, kind of, narrowing down the options that you have. I think the cool thing would be that you do see foams where automatically you pick up that there's performance that you're looking for, and you see that almost right away. But then it's kind of that second tier of testing to make sure that it has kind of every other attribute that you need it to have in terms of, the long-term durability, the continued reaction and performance, shot after shot after shot. And then you essentially narrow it down until you're like, oh, like, I think we've checked all the boxes, and I think we're at the foam that we want to move forward with. I mean, Max Rebound was a little different because we were already using it in Axis. So it was more just adapting the material to work with that core, make sure we get the right thickness. But we'd already done a lot of the work with Axis previously.
And you always, the haha moments are pretty rare, because there's always a compromise somewhere. The perfect material I haven't seen yet, so you always have to balance it out between, can we afford to put this product in our pad and still, compete, or we're going to end up with a $5,000 retail price on a leg pad? Or is this, maybe this foam has crazy rebound properties, but it's, 500 grams when we're looking for 100 grams or something like that, So most of the time it's always balancing out the different aspects and the different features that you're looking for. It's very rarely is it only one characteristic that is the be all and end all of a selection of a material when doing testing like that.
Oh, sorry, unmuted myself there. We've got a couple questions that came in actually that tie into this nicely, and I feel like I might put you on the spot here a little, Kaylee. I apologize. I got one from Kevin Arnold. NHL goalies today using control or max rebound? I know here in Vancouver, the first time I saw Thatcher Demko hit the ice in eFlex for the first time, before I even knew there was really a max rebound, or we hadn't really gone through the line ourselves because the line wasn't launched, something was different to me. And sure enough, as it turns out, he was using the max rebound. Is that the preference for the most part, or do you have some using control as well in the NHL?
Yeah, I mean, I think, to your point, I love the Demko story because we connected on that early about his first trial with max rebound, and how you noticed it right away, and we, were able to validate it together, and it was like, yep, there it is in action. Frank can actually probably speak to it a little bit more.
I right now that I know of, our roster is all max rebound, I think.
But that said too, I mean, the NHL is one, but when we look at, our CHL goalies, NCAA goalies, etc., I think the split is still pretty close overall. I think just what we find with our NHL goalies, a lot of them are more inclined to have, even if it's an eFlex pad, something stiffer, and max rebound does kind of complement that concept. But in the other leagues, we still have a lot that are opting more for that control rebound feel.
Okay, and another one that's just come in here, and again, folks, if something comes up and you want to ask, we'll try and get it answered. Hit the Q&A button. There's actually quite a few in here. Matt Morrissey with a good question, and this is something I think would be beneficial for a lot of people to learn. The product development life cycle, like what's the timing, what's the duration to go from pad design, concept, all the way to market release? I think a lot of Joe Public thinks this is a pretty quick thing, but it takes a lot of time, and there's a lot of effort and sort of processes you have to go to get from design to buying it on the store.
So, I mean, I would say in terms of ideas and whatnot, like, you're thinking pretty far ahead. Like, I can even just give you an example. Frank and I spent the morning together here. And we're talking about what might be in 2024 and 2025 products. So, we just launched 2021. We're basically cooked for 2022, and we're having these conversations, 3-4 years out. But in terms of the actual design cycle, our designers are looking at early samples, over 2.5 years ahead, where we've got the concepts in place and can get to the point where we're making samples. In terms of market feedback, I lead a lot of the surveys and the kind of field work that we do to get opinions and to just see what features are beneficial in the direction we should take. That's happening 2 years out as well. That helps refine us. So really are working ahead. If you guys want to add anything from like testing side and.
No, definitely from a innovation side of it, we're looking at things that are, we're looking with our university partnerships. We're always looking for new answers. So we're looking 4, 5, 6 years down the road easily. So we're always trying to find the solution, and we're feeding it back to the designers for exactly that 2.5 year kind of design cycle.
Yeah, I mean, the ideas are always flowing for stuff that is down the road. Now, if we want to get more, to the basic structure of it, I think a typical development timeline is usually 24 months, from, the business case and starting doing the lineup and really creating what's the lineup going to look like, and then sketching the first designs and the first ideas and laying down what is the features and benefits that each product are going to have. That's usually 24 or 2.5 years prior to what you're going to deliver to, prior to the day where it's going to deliver to the store.
Okay, I want to shift a little bit and get back to the pads, get back to the eFlex, and as everybody can see here, one of the things that jumps out off the page, especially when the early graphics started coming out, was that control knee roll, sort of the unique makeup of the angled knee rolls. We've already seen a question come into the Q&A from Matt Morrissey, a good question. Why the triangular knee rolls on the new eFlex 5? So I'll turn that over to you, Kaylee, and your team. Walk us through the process. Was there ever a point where you're like, hey, do we need knee rolls at all on eFlex 5? Like, what goes into that decision? And then how do you arrive at something so unique and so new as you have with the eFlex 5?
So, I mean, that is just the question of all questions. Does eFlex need knee rolls? I wish we had a poll function on Zoom so we could do a quick hit the audience up and see where they stand on it. But essentially, like, that was key in eFlex 5, like visually one of the biggest things that we needed to answer. So what it came down to is we have had concepts that don't have knee rolls, and we did have a concept that did. We have a goalie advisory committee that I think we've mentioned previously with some top goalie coaches, the goalies that they work with. We have our pro reps, we have our retail reps. We were able to gather feedback from all of them, send out surveys. I visited a few tournaments to visit some youth goalies and start to get opinions. And the unanimous consensus was that eFlex still needs knee rolls. That even if people understand that from a functionality standpoint, there's less to them, they still just want that visual cue, and they like that visual cue, and just what it means to them overall. So we knew we would move forward in that direction. But then second to that, it was, well, if we're doing knee rolls, how can we optimize a knee roll design? And you think about a traditional rounded knee roll, and everything that we know about rebounds and round just doesn't make sense from a predictability and accuracy standpoint. So we knew that flattening them was going to be part of that process. Again, just looking at the construction, the materials underneath, our introduction of the molded knee technology to, again, just optimize the direction of the puck. If a goalie's going to make sure that they're square and that their angles are aligned properly, that the pad's complementing that. And then the last element is, there is a degree of flex with our eFlex pads. So we need a design for those 3 knee rolls that when the pad is flexed, when the goalie's going in the butterfly, that the design's complementing the goalie's movements, not working against them. So ultimately the design that we settled on with, you know, kind of the new shape with the flattened design, that's how kind of everything came together, and we introduced the control knee roll concept.
I keep forgetting to unmute myself. Sorry. Not that bright. I know there's a testing process. Like, you have a test team as well. Like, is there feedback there? And how much in terms of testing with you, Ryan, like when you were testing those knee rolls and that predictability of rebounds, like how involved were you in that process? And then how much do you rely on some of the feedback on the ice with goalies? I know CIS and high level goalies that are part of your test team to sort of validate some of those things.
Yeah, no, we definitely lean on our partnerships with our field teams. We see a lot of them giving us nice feedback on the different concepts. It's always good to work with them. We also do everything in the performance lab up here, so everything that we see from a rebound perspective pointed to just what Kaylee was saying, getting rid of that kind of rounded shape, giving us more predictability in the rebound. But across the board, we were seeing that it was a good idea moving forward with that.
And I should mention, Kev, before we move on, that, you know, you mentioned we're in our performance lab, but I know you probably can't see it too well in our screen, but literally behind me here, you might kind of catch the glass and the boards of a rink. Like, this is an entire almost three on three sized rink with basically the best synthetic ice that you could possibly have. So we can do on ice testing. We can literally walk up to our office here and have a testing facility. So it's a pretty cool asset for us.
And although I will say you're speaking to, you know, a group of goaltenders here. So some of us, when we hear 3-on-3 rink, we shudder a little bit because it's not always the favorite for us goalies. And then, sorry, Kaylee, you spoke to the idea of flattening it out. What about the angle of it? Was that all about sort of maintaining that flex and having the way the pad went to the ice? Did you guys do a lot of testing in terms of, it feels like the seal has improved a little bit as well when you drop to the ice in the E-Flex 5 from the E-Flex 4. It feels like that the way it's the pad sort of, I'm not describing this very well, but when you go down to the ice, like that thigh rise doesn't want to lift up. The way it sort of flexes down to the ice, it feels like the seal through the top of the thigh rise has improved. Again, can you speak a little bit to some of the testing, and am I just talking out of my butt here, or is what we're experiencing being matched by what you were trying to achieve by having that angled knee roll?
I mean,
I do talk out of my butt a lot. I apologize.
I'll let Frank jump in more because he can share some insights on the actual kind of inner stabilizer area and the thigh rise landing that you're speaking to. I would say when it came to the knee rolls, it was more like, we don't want a design that's working against us. We want a design that's working for us, more so just in relation to general flex, you know, overall functionality. But when it comes to the landing and the seal that you're speaking about, I think that's a little bit more of kind of a different element of the construction of the pad, but we can definitely highlight that as well for you.
Yeah, I mean, in terms of landing, it's always been an issue of the E-Flex pad for since the first iteration, that the seal was always a little bit off at the tip of the thigh rise. So what we did is we really reopened the pad and looked at the construction and really made sure that everything was built to achieve the straightest flex as possible, because there's a tendency, and I do it a lot, to lean on the top of your pads with your glove, especially on the glove side, but sometimes on the blocker side as well, and just to put weight on the top of your thigh rise sometimes when you're in not when the puck is at the other end of the ice. And that will cause the pad to torque a little bit. And some goalies even like to have a little bit of torque, a little bit of twist in their pad. So we tried to create the pad that was flexing with the most stable actual flex possible. And so that was all part of how we looked at the thigh rise. But like Kay said, it's a little bit a different story as the knee roll design.
Kev, that mute button is just going to be the end of you.
In my defense, I am also trying to run and monitor the Q&A. So, but the truth is, as Hutch can attest to, I'm just frankly not that bright. So I apologize for that. I wanted to get into a little bit of some of the other specs. You know, I wanted to, Frank, and I was originally going to ask Francis this too, sort of some of the changes, especially with the glove. You know, it's still a 600 break, but we saw a little bit of, you know, it feels like a little bit of a different feel in this one. So maybe as I share it on the screen there, maybe, and I'll take it off in a sec, but can you walk us through some of the changes, you know, in this compared to past iterations of the 600 break on the eFlex 5 glove?
Yeah, on the 600, it's really a very subtle combination of changes that made I think what ended up being a big difference. Again, in the 600, there was a slight tendency of the glove to bite a little bit at the heel before it closed at the top of the glove. And so we really just went back and looked at the patterns and did a couple of very subtle pattern adjustments to really correct that little issue where the heel of the glove would touch before the tip of the fingers. And so it's really just a question of pattern adjustment and very slight modification of the shape of the inside of the glove, and more precisely the core of the glove. So I'm sure all of you guys know that within a goalie glove, there's a piece of plastic, a solid thumb that extends into the cuff box, and that piece of plastic is located in front of what we call the core of the glove. So basically the catching area. And so this is really super important to how a glove feels and closes. So just slightly modifying that pattern and that heel area here at the bottom of the glove really helped us get a much better, much cleaner, and much easier closing 600 on the eFlex 5.
Okay, so that sounds pretty simple, but I'm guessing there's a lot of back and forth and testing and processes, and how much of it is that more of a field test, Frank, and how it feels on somebody's hands, or is there actual, you guys come up with testing to sort of measure closure and measure those types of elements in a glove?
We do, and maybe if you want to jump in, we do have physical testing where we can, measure the amount of force needed to close a glove, and that has some value. I mean, we do it, and it has for sure it has a value. But at the end of the day, I think field testing in that specific area really is super important, and that's why we work closely with our partners and our internal field testing, but also teams that we work with where we send equipment and get feedback. And it's really super important for us, especially with a goalie catch. I think it's really such a touch and feel type product, so I think it's really important to, yes, you need the numbers and the computers and the machines to tell you, how many newtons needed to close a glove. But at the end of the day, you need the validation of goalies that tell you, oh yeah, this one feels, there's more snap, there's more, it's really hard to define snap in a lab. Whereas with a goalie, it right away they know what you're talking about.
So Ryan, you're now a goalie. So do you know what he's, or are you still thinking newtons, or is it just strictly feel?
I have to say, the amount of time I spent in the lab, I want to talk about newtons, but every time I talk with these guys, they definitely convert me to the goalie life. So that's good. It's a bit of both.
And is that, I was going to ask, we've talked a lot about impact testing as well. And, it's interesting. You said, Frank, like we could find a material that might create rocket ship rebounds, but if it weighs 5 times what the material we need is, it doesn't work. I'm guessing there's a little bit of that in the testing of a glove. You could probably create one that needs less newtons. I don't know how many that would be, Ryan. You would be the expert there, but it also still has to be protective enough. How much has materials like using D3O in the palm allowed you to maybe walk that line a little closer to, the snap over having to make it so thick that it won't close in order to stay protective?
Well, I mean, when you mentioned D3O, you mentioned one of those materials that are really close to being an ideal material. Yes, it is very expensive. It does weigh a little bit more than some counterparts that some, similar foams that have similar properties, but it really has this beautiful, it has a great curve. So the way it manages impact as you increase the severity of the impact is really impressive. And so it's one of those materials that we're really lucky to have a partnership with this company. And wherever we use D3O, generally we see a very clear result, not only in our lab testing, but also with our field testing. It's one of those materials that translates well from the lab to the ice.
And you mentioned partnerships and you mentioned testing, and with an apology to anyone who is involved in the blocker, just in the interest of time, I am going to skip it over and move to the chest and arm, because I think this is one where partnerships, as we show off now on our screen, the eFlex 5 chest and arm protector, we talk about the increased use of D3O and that great material. But I also think of the partnerships. Obviously, we've had a chance to meet Ryan Frayne, and I know that's a partnership you guys have worked together on. And we've been over, how a chest protector should move compared to how a lot of goalies walk into the shop and, pretend, in my case, maybe do their hair back there, but how it actually should move for the function of a goaltender. How much can you walk us through? Because there's been some big changes in this product. Maybe some specifics of the process, Ryan, the testing, the impact testing of a chest protector, and what sort of that process is like, that balancing sort of biomechanics with protectiveness, and how you sort of come to unlock that formula as best you can each time out.
So Cam, I'm going to jump in on one thing before we go here, because it's going to be, you didn't miss anything, but it's important for the chest, but it's just important to note for the pads we talked about, for the glove, because I know there's probably a few goalies of different ages and their parents on this seminar. Is that everything we just spoke about in relation to modifying the 600 glove, in relation to the improved knee rolls and the thigh rise seal that Frank was referring to? I think a lot of people just jump to thinking about the eFlex 5, but this is relevant to our 5.9 model that's available in senior and intermediate. And then for the junior pad, our 5.5, all of those improvements are reflected in that product as well. So I just don't want people to think that it's only in that elite product. We're carrying down as much of that as we can into the entire product line. And we'll talk about the chest protector now as well. And again, the things that we're talking about here, we're bringing down into those other models as well, just for consideration as we continue to look through each product.
Yeah, and I was gonna bring that up when we talk about flex testing as well, and we get into how you test some of the flex and measure that to make sure it's consistent throughout the lines. But a really good point. In terms of the chest protector, one of the things I didn't ask there, amongst all the different elements that go into building it, something you're starting to look at more. So maybe I've kind of multiple parted this on you already, but the biomechanics, the work with Ryan Frayne, but then also sweat, thermodynamics, like how much are you, Ryan, how much are you measuring? There's perforated foams, I noticed, on the eFlex 5 to allow it to breathe more. I'm guessing that's more than just, hey, let's put holes in it, it will be cooler. Can you share some of the testing that goes into determining how a goalie sweats and overheats compared to, say, a player? Because I know you do work on the player side too.
We need Darren Millard to give you a hard time for whatever the past two questions were, but we will answer everything that has been covered over the past 2-minute question.
Consider this a test.
Yeah, so we can start though with what we refer to in fancy terms as thermoregulation, but basically goalies sweating a lot. So I'll let Ryan take it from there.
Yeah, so I'm sure most of us have unfortunately heard from players that goalies are just standing in their crease and not working as hard, but I can attest, I've seen both sides. I can definitely say goalies are working harder and getting much hotter. So what we've done is we've done a lot of research with thermoregulation. We're looking at different heat maps, different hot spots on the body. So nicely done, Kevin. You pull up the heat map there. Sort of what you're seeing is hot spots that are getting generated by the arm and body, really in the points of contact with the body. So what we've done is we've tried to ventilate all of those spots more, and we've worked with our goalies, getting good feedback and seeing the different thermal images of the different perforations, how much ventilation should we put, how much protection do we still need to keep, and we're just working our way towards allowing these goalies to breathe a little bit better. So
I'm gonna share. I shared the back one. Here's the front one.
Yeah.
Yeah. So
you can see a huge buildup of heat up in the top, and on the back you could see it was very much the shape of the arm and body back plate. So we're putting a lot of emphasis into letting that breathe a lot more, because our goalies are overheating and we all know it, especially on those 3-on-3 games when we don't get a break.
I'm still shuddering at the mention of 3-on-3.
to backtrack a little bit to part one of the never-ending question, talking about Ryan Frayne, talking about impact testing, flexibility and whatnot. So, for those that have listened to previous InGoal podcasts, Ryan was on one time and we've talked about some of his research before. He's really done a good job at looking at the relationship in the sternum protection piece, the floaters, and basically how the movements that are necessary for a goalie correlate to those pieces. So the research that we've done with him is something that's kind of at the forefront for every design that we now work with. So when you look at the shape of the sternum and the way that the floaters can move and overlap, that's all based around the biomechanic research that Ryan's done. So ultimately you're getting a deal combination of impact protection, but also the mobility that you need specific to goaltending movements, not just movement for the sake of movement, but actually dialed into what we know you need to be capable of doing as a goaltender. And then, internally, again, looking a little bit further just at how can we add segmentation, get proper mobility, what foams we need to use to leverage, a combination of protection, but also movement where you need to. So that's where these two teams are kind of working really closely together to get to the final product.
Yeah, so in the research side of that, we're doing a lot of motion capture, getting different movements. And so Ryan Frayne helped us a lot with that, getting the biomechanics of the shoulder movement down, not just in random swimming motions, but as Kaylee said, really in the save motion. And then we also looked at sort of how long it takes you to get to a position. So not just can you get to it, really how much resistance is there. So adding flexibility to the core of it, making sure you can get down and freeze a puck or get down low for a glove save, all those options.
The other thing I wanted to look at a little bit too, and I kind of got out of order here a little bit with going to the chest and arm, but we talked about the flex testing, Kaylee, and we had an interesting video that we were going to share. Ryan, I was hoping you could maybe walk us through it a little bit, but first, Kaylee, the importance of I never thought of flex testing, like what flex testing would look like. The importance of developing consistency, not just the flex profile you want in an eFlex 5 Pro, but maintaining it as the materials change a little bit to 5.9, 5.5. And then also you're looking for a little more flex in the youth pads. Is that correct?
Yeah, so at the youth and junior level, again, that's where our goalie advisory committee is key. That's where, we have the ability to connect with them and connect with their younger goaltenders to see what they need and what they benefit from. And overall, for both Axis and eFlex, the concepts of both pads are still important to those younger goalies, but generally speaking, the boot needs a little bit more flex. Frank mentioned torsional flex earlier. They need a little bit more give to be able to master, just basic goaltending fundamentals and whatnot. So you're looking at that combination for, the 5.5 or for our Axis 1.5 pad. How do you give them a pad that performs the way they need it to? So Axis still kind of kicks out a rebound. eFlex gives them a little more control, but also, kind of adapts to their movements. But then for our 0.9 series, so our 5.9 and our 1.9, we're looking to see how we can keep it as close and consistent as possible with what we're doing in eFlex 5 and with Axis. So we've actually worked through kind of a series of motions, again, just looking at common goaltending, positioning and whatnot, and to see how we can just test for flex, to not only see the difference between Axis and eFlex 5 and ensure that we're kind of hitting the points that we're looking to achieve, but then also have that consistency down the line. So I think you could probably pop up that video and Ryan can speak to you about what we're looking at here.
Yeah, I was just going to share that now. And I was going to say, Ryan, feel free to go full Howie Meeker on me here. Just tell me when you want it stopped and paused, and we'll go from there.
Yeah, sure. For now, you can run it. We'll walk you through it. So on the pads, you can see a whole bunch of different little silver markers on there. Those silver markers are what allow you to do motion capture. So that translates to what you're seeing in front of you now. So a little bit of the dots on the screen. So what we're looking at there is kind of what the different angles that happen during a motion. So when you're pushing across, is the pad bending? Is it got anything torsional involved? Is it staying nice and sealed to the ice? So is it bouncing up and down? All those things are sort of what we're looking at in that study. So again, with this eFlex pad, what we're looking for is just getting a nice seal to the ice with the flexibility to be able to move well with the goalie.
And then the chart on the right, what's that with the pad ice angle? What are we seeing there as that moves along?
So that's telling you the angle of the pad to the ice. So it's just very quickly sort of telling you where the player is along his motion. So you see the pad lifting up to a sharper angle and then coming back down to the ice. So that's the curve that you're seeing. And what we want to see is they come back down to a nice resting position and they don't bounce around at all.
And are you looking, sorry, I was going to ask, are you looking for like speed, like how quickly it gets down to that resting motion as well? Like, is that all part of it? Like, I see all these different things. I'm trying to think of all the different elements you must be trying to measure and look for in these things.
Yeah, so that's something we consider like responsiveness. So making sure that the pad moves well with your leg. So not only is it doing what you want it to do, but it's doing it as quickly as you are. The last thing you want is a pad to be feeling like it's dragging behind you or delaying you at all. So looking at that too it's a good point, Kevin. That's what we do.
Okay, and so this one is more of just a butterfly drop on this next video.
Yeah, and this just happens to be an amateur goalie helping out here. You might recognize me. So
Ryan's giving us a base.
That's the baseline of what you maybe don't want to do, and then we bring in our Concordia guys to show us what we're doing for real. But,
and again, what are you looking at here in the chart?
So there, same thing. You want to see the pad coming down nice and smooth to the ice, sealing off, not bouncing.
You can see the difference here, though. I mean, just on the most basic fundamental. The other one, the lines on the right started down, and then you saw it come up as the goalie moved to slide across. In this one, if you recall, Ryan started standing, so our lines start higher up, and then we see the drop and the reaction as he came back up out of his butterfly. I mean, essentially, like, we have Ryan, who is phenomenal in, guiding these tests and being, an early test model. But then we even have Aiden. He's actually kicking around in the background here. His office is in this lab because that's how closely he's working with the data. But he can even break these data points down further for us. Like we said, we have all these different motion captures. We've got speed, we've got flex, we have so many different measurables. And so he's basically just an expert in that biomechanic research side of it. It can help us derive even more from it as well.
That's fascinating stuff. Awesome. That's fine. How do you balance that? How do you balance those test results with the field? Again, we take it back to the field testing. You mentioned the Concordia goalies, the CIS goalies you work with. You're obviously working with your advisory committees and your different goalie coaches. Obviously, we have a good relationship with Eli Wilson, who I know has been in there and helped out with some of those elements. Where do you combine that? Where do they, again, it's that numbers versus feel. We're having an analytics versus eye test debate here. How much does it become a little bit more about the numbers when we're talking about a pad, or do you still need to balance that feel and flex profile as well?
I would say with something like this, we know the feel that we're looking to achieve. When we set out to build a pad, we have something in mind and it's built directly off feedback or how we want something to evolve. And then it's just this validation, because with Frank and Francis and everything they know about, just our internal designs and everything, they're pretty dialed into how you can modify a foam ever so slightly and kind of take that step that you're looking to and then you're validating. And a lot of it's not really extreme. A lot of it's more on the subtle side, I would say. So I think a lot of these tests are more validating more than anything, and we know the feel is there, and it's just about that consistency that we talked about earlier. I would say rarely would we come up here and have a product and say, whoa, we weren't expecting that. It's more just let's get a benchmark, and when we build out the rest of the line, we make sure that we hit those same points as well.
Yeah, and as we're working our way through all this performance lab study, every time we're always asking for the feedback from the player as well. So not only are we asking the data to tell us what's going on, at the same time we're asking the player, what do you see, what do you feel while you're doing the motion? And often their feedback is directly related to the data. So it's nice to get both sides of it, and it's even better for Aiden because he can simplify. He knows right away. A goalie can tell him. A goalie who knows what he's doing tells him right away, my pad feels like it's bending. My pad feels like it's twisting on me. And then he's able to go and look at the data, and he right away he can find it there. So it's interesting to see both sides when we're up here.
It's interesting. It reminds me, again, we're talking about goaltenders. It's when the analytics match the eye test, right? And that what you're seeing is being matched up by the numbers, it sounds like. A couple more I wanted to get into. One thing I was curious about, consistency is something we've heard from pros over the years. One of the reasons they've liked and loved CCM product over the years, injection molded parts in the gloves and in the pads that help sort of have that consistent break, that consistent feel. I remember years ago talking to Luongo about how he could just get them, throw them on, and play in them the next day. Something we've heard from subsequent goaltenders. Do you test like from durability and what those injection molded parts and the investment CCM's made in injection molding? How much of the test do you do over time how much are you looking for, hey, this is still performing this way after a period of time? And do you see discrepancies? Like if it changes like from one pad to the next, are you looking to make sure there's a consistency that you maintain the consistency that we've come to expect, again, because of the investment you've made in those types of injection molded parts?
Well, for sure, we always, as part of a full QA and QC process, we always look for consistency into our products. So just as you would for any other product that you manufacture, through your production line, there are different points where you just have to inspect and measure and see if your product that you're building is done so according to the specifications. So that is a pretty standard procedure that any manufacturer would do. So of course we do that. Now, like you said, we went from more traditional ways of manufacturing product to these more innovative way of manufacturing parts for that very reason. And this is definitely something that we are looking to improve in the future and incorporate more in the future. And I think, that's what's interesting about the world right now, and the new technologies that are appearing, is that it's always allowing us, engineers, designers, and product managers to have more tools to create a product, not only that performs better, but that is more consistent. If we go back 20, 30 years ago, it was really all about the craftsmanship of that one and only person in your production line that knew how to lace a glove, So as we move forward to the future, we're going to be able to have more consistent product with newer, more innovative methods of manufacturing.
Okay, and I probably jumped the gun there. I talk about injection molding, Kaylee. Like, do I feel like, should I explain that a little bit, or can I let you explain what the difference is between, there's probably a little science here. Again, not that bright. We can tell by the mute button, but that certain, the idea that you take a flat piece of plastic and you heat mold it into a shape versus injection molding it into the shape you want, how the one that's injection molded, there's something about everything wanting to revert to its original form. There's probably a law there that much smarter people than I could talk about in terms of what an injection mold does for you in terms of durability and in terms of consistency. Can any of you just sort of, rather than just having me explain it so poorly, maybe speak to that a little bit?
Sure. I mean, so if we can compare just simply the two processes that you spoke about, first of all, like you said, compression molding is a molding method where you will take sheet stock, in the case that we're talking about, high density polyethylene, and we will heat it to a certain level where the plastic is malleable but is not molten. And you then compress it between a male and a female part, basically mold, and you compress it, then release, and you then have to let it rest or cool down on a jig so that it doesn't flatten out, right? Because it's still at a very high temperature. And so this is a process that is very inexpensive because the molds are fairly simple. You don't have to heat it that much. And the operation is pretty simple. And the pressures that you need aren't that high either. So it's very efficient, and it's what's been used traditionally. But like you said, there are problems with consistency. Oftentimes in some factories that I saw, they would stack the compressed parts on one another. And so the parts from the top would be well molded, where the parts from the bottom stack would be all flattened out, and they would all have variable shapes. And so with injection molding, what you have is you have you have plastic pellets, plastic beads that are completely molten and then pressure inserted into a mold that is sealed, that is closed. And so the plastic is rushed through that mold, and it's literally injected into its shape at a liquid well, semi-liquid status, almost liquid, very well, way past its melting point. And so once that plastic has solidified, there are cooling channels in that mold. And once that plastic has solidified, the mold releases and the part is solid at that point. And so as you can imagine, since the plastic has been injected in a liquid form, all the molecules, all the fibers, for a lack of a better word, of the plastic are really formed into that shape that you just injected it in. Whereas with the compression molding, you still have your original direction to your plastic of your sheet plastic, or your original sheet plastic hasn't been melted. So the plastic is still in its mind, if I can say it, still thinks it's a straight sheet of plastic. Whereas your injection molded part really has melted and reformed into a different shape completely. So I guess I explained it.
Yeah. For those going back to school, here is your perfect benchmark for your science teacher. What you can share, what you learned this summer.
It's all I'd say. The answer was a lot better than mine. From now on, when I do a review, I'm just going to clip that, Francois, if that's okay, and I'm just going to insert that rather than me trying to write it out. I think that was perfect.
Sure.
Because I know it matters, and I know it's a reason we've talked about that consistency and also durability in terms of those parts maintaining their shape longer, whether it's in gloves or even, injection molding in terms of the shape of a core and a boot structure and a pad. So I just wanted to make sure I had somebody smarter than me explain it, because I do a half-assed job every time I write a review. You've now set me up for future reviews. Listen, another product that's not necessarily new this year, but it's that time of year where a lot of people are in the stores, hopefully getting back to hockey. Hopefully everyone's in the same boat and we're all getting back on the ice. Masks. Ryan, I know you're part of this on the other side as well with the players. We won't hold that against you. But where are we at with mask testing? What kind of testing do you do? I don't mean at the NHL level, but I mean just in terms of what are we doing? We saw the fluid pods on the Axis mask as something different. Where are we at, and what kind of things are you looking at in terms of the next steps of protection for goaltenders at a time when, even if it's not in a 3-on-3 rink, a lot of these kids shoot pretty darn hard?
Yeah, I mean, we work with our partner again. So we work with the University of Ottawa, who have an incredible lab there with an incredible team, and we work with them and our internal physical lab down here. And so what we're doing is recreating all the different impacts. So we're looking at not just what type of impacts are happening, but when are they happening, how frequent are they, where are they hitting on the mask, and really getting a deeper comprehension of exactly what types of impacts are happening. Then we take that and we combine it with our trusted materials and new innovative solutions like exactly the fluid inside, which we worked with them on. So that's just figuring out how to take an impact that's very severe, as we know, and transferring its energy less so to your head. So in very simple terms, but trusting materials like the fluid inside and the D3O material, which has proven time and time again to work very well for our puck impacts. Just combining those into the material.
I'm guessing this is an area where the testing in the lab is a lot more preferred to testing for real, although I got a team full of beer league guys who seem to want to test the theory every time we hit the ice for warm up. I'm sure everybody can relate. This is one where testing in the lab becomes more important.
Without a doubt, we prefer putting it on our dummy's head instead of my own head.
We've talked a lot about, we've talked about impact studies, sweat studies. We've talked about, thermoregulation, pardon me. That was the proper term, Kaylee. Flex, impact, all these different things. Where's this headed? I know you can't tell us what's next, although I do have a question. Kaylee's going to kill me. I don't know if she's going to kill me for it. I do have someone who's asked, I'm putting you on the spot here, Kaylee. When will we see full screen printed, all those cool graphics we've been seeing for the college kids? Can you give us a hint when the rest of us might be able to see that? Or do we have to wait for that one? We did not ask her if we could approve this.
I'm not going to give you a hard time because I haven't sent you a set with the InGoal logo across the front, and your goalies on the call haven't been able to see it in person. But it is not silk screening. It is only the best that we could possibly offer with our UV printing. So just one distinction there, that silk screen, it's kind of like compression molding versus injection molding. UV printing is, the best of the best, and that's what we've invested in for these graphic programs. So there's a little tech 101 for when it comes to retail. I would say to stay tuned for a few more fun designs at those elite leagues, and then continue to pay attention into the spring of 2022 for the next step in the offering there.
And on that note, without giving too much away, where, like Frank, Ryan, what else are we, like, what are we looking at? What's next for goalie without, speaking specifically to product? Is it just constantly experimenting with new materials, new designs, new ways to move on the ice and make equipment that moves with you? Is there anything that excites you more than other things when it comes to materials or opportunities, or where are we even seeing preferences? What are goalies looking more for now than maybe they were a couple of years ago?
Well, without giving too much intel into what we're doing, I would say that a lot of where we draw our inspiration is our partnerships with our goalie advisory board. So, and Ryan Frayne is a big part of that, and also some goalie coaches that give us an insight into what is being thought right now to kids. As you know, and you probably know better than anyone else, the position and the way the position is being thought, and the new techniques that are appearing have changed completely over the past, 2 decades. And so we're really relying on that knowledge that we're drawing from the goalie coaches, our goalie advisory board, to basically to inspire us into our new innovation and design. So this is really something that we're relying on. And I would say, because I don't want to go into specifics, I would say that cutting edge goalie technique is what we're looking at in order to fuel our design for the future. Now, what particular technique and what particular detail, I don't want to go into that right now, but I can tell you that we've got some stuff in the pipeline.
Okay, there was one other one, and I don't want to end it on this one. So I got one more question beyond this, because Kaylee, as you know, I am famous for one more question. But we did have one. I've lost his name here. I've lost the sort of the original question, so I apologize to the person that asked the question, but I thought this was an important one. They can't find eFlex 5 anywhere. It's sold out in all the stores. So can you guys speak to some of the challenges right now in terms of supply and demand and international shipping and all the things that go into, for example, the eFlex 5 stick not being as prevalent on shelves right now as you might have hoped?
Yes, so it is a good question, and I'm glad the goalies are curious about it, and we wish we had some better news. But for those of you that have been paying attention to the news cycle and everything that's going on over the past year, whether we like it or not, there are some challenges that COVID has, basically caused not only on our industry. If you look at the automotive industry, you look at, basically any industry out there that you're interested in, there's been some challenges this year, and our stick was unfortunately one that's been impacted by that. So in order to not keep people on their toes and to be continuously on the lookout for it, we ultimately, with our stick team, decided to move the eFlex 5 Pro stick into 2022. So the 5.9, which is a fantastic mid-level stick, it's got a really nice flex profile to it. It's got, a nice a new shaft design, for example, to assist with durability, but also a really nice feel and balance. It is in stores, but the eFlex 5 Pro will be coming out next year. So stay tuned.
Okay, and last one, in terms of, again, without giving away too much for the future, Kaylee, for you, what's next? Like, how long do we have to wait? Is it going to be spring before we see that next iteration? Do we keep our eyes peeled at goalies testing gear? Where are we looking for the next big thing from CCM after we all go buy our eFlex 5 sets for this season?
Yeah, exactly. So, eFlex 5, Kev, come on, I feel like it literally just came out. I think it's a great product line for those that are, inclined to that eFlex style of goaltending. Next year, since we just came out with the eFlex, we will need to balance it with an offering for goalies that are looking for something a little bit different. So I don't know, I'll say this. I've been talking to a few people about what's coming next recently, and I'm excited every time I can talk about it. I think they're excited every time they hear about it. And I'll simply say, over the next few months, if people keep their eyes peeled, tough to say what they might see, but they might see things. I don't know. I can't say much.
I just needed, Kaylee, it was a bad question, but I just needed one more question. That's the reality. So I had to put you on the spot. Listen, we've got a few other questions here that I'll try and get to, just with typed answers that I can get to there. But we're sort of over the time we'd allotted for this. What do you know? Kevin's in charge, and we went over the time. I think everybody probably expected that. But I just wanted to thank the three of you for taking the time to join us. As much as this was a bit of an overview of the eFlex 5 line, we wanted to make it more about all the work that goes into creating a line of equipment. And we really appreciate three of you, and Francis not being there. Hopefully we have an announcement soon on social media, but really appreciate you taking the time to sort of fill us all in on what life is like behind the scenes like this. So thank you very much to all three of you, and hopefully I wasn't too big a pain in the ass. We'll get to do this again in the future.
Yeah, no, I think it was really good. I think I speak for all of us that just talking about goalie with goalies always happens. We could go on and on about it. It was an hour and 15 minutes. I think we're almost at, but it felt like 10. I think we all enjoyed it, even with the tough line of questioning. So we appreciate everyone that tuned in, and hopefully something we'll do again down the road.
Yeah, for sure. We're always available.
All right, perfect. Ryan, Kaylee, Frank, thank you very much for your time. And for the rest of you, if we didn't get to your questions, I think I got to most of them. There was a bunch. Feel free to send an email to kwoodley@ingoalmag.com, and I'll do my best to get it answered behind the scenes and get it back to you. So thank you again. We're getting a lot of thank yous from that are coming in on sort of the chat, and even in the Q&A there, people are sending thank yous. So I know everybody enjoyed it. Enjoy the rest of your day, guys. Thank you very much for the time, and we'll talk to you soon. And a reminder to everyone who's tuning in, if you want to go back and watch this, we will have a version of this produced and online for anybody to watch probably in the next couple of days. So, yeah, I just put Hutch on the spot.
No pressure. All right.
No,
Well,
that's
thanks a
all.
lot, guys.
Thanks, everyone.
Yeah.
Thanks for taking us behind the scenes. All right. Bye, everyone.